Assalamu alaikum wa rahmatullahi wa barakatuh. Once again, we are going to go for the last session of the day, which is related to structural layouts. So we are going to learn basics of structural layouts. Since tomorrow we are going to take the detailing of different elements, and based on the knowledge that you have learned or you are going to learn today from the structural layouts and tomorrow from the detailing, we are going to be ending up this week by tomorrow's second session with the estimation. So before estimating, I should know uh, uh, I should know how to read the schedules and the steel. I should know how to read the layouts. Before reading the layouts, I should know as well the basic construction stages and then the cookie. That's why we try to relate each one of them to the other one. Okay, so we are going to go for the structural layout. Now, in the structural layout and schedules, different things we are going to take today, starting with hidden beam, inverted beam, sunken slab layout, beam layout, column layout, and then foundation layout. So these these three things, although they are not from layout, but they are going to meet you more often. Okay? You are going to see them, so you should know the basic things about them. Okay, especially hidden beam and sunken slab. In most of the buildings, you will be having these. Okay. So going for the first one, which is hidden beam. Um, there are two names for this particular hidden beam. Somebody is calling it hidden beam. Others are calling it to be concealed beam. Okay, concealed or hidden beam. It's already obvious from the name that this particular beam is hidden, means it cannot be seen. Okay, so I cannot see it like the other regular beams. Why I cannot see it? Because it's inserted inside something. So it's available, but it cannot be seen by the regular person. Where is it hidden? It's hidden inside the slab. So if you go and see, this is my slab. Okay, this is my slab. This is a cross section of a slab. These are the reinforcements of the slab. So we have short side bars, long side bars. And you can see it has been mentioned here, like for example here, longitudinal bars. Here we have transverse. Longitudinal refers to the uh, one of the sides. Let's say if we are saying it from X, so longitudinal refers to X bar. Transverse is the other side, so it refers back to Y. If I'm saying it from Y side, so this is going to be Y and that's X. But since the reinforcement is at the bottom, so this is more of X. So this bar is representing X bar. This is representing Y bar. This is representing X top. This is representing Y top. Now, if you go and see here, now we are having our beam here inside the slab. Okay. So within the depth of the slab, we are having our beam. Now, what is the main difference between regular beam and the hidden beam? One, that the hidden beam is inserted inside the slab. Okay. The other one is not inserted inside the slab. Although in certain scenarios you might be having T beam or L beam, but it will not be hidden fully inside the slab. Okay. The other difference between a regular beam and then the hidden beam is the depth and width. Now, normally, if you remember while uh, taking any of your design courses, you remember that the depth of the beam is more than the width of the beam, and that's due to the loading condition and the stiffness. If you remember, for me, uh, while doing the beam is very important to take the deflection, and it's very important to take the bending moment and shear forces. Okay. So if you remember the basic equation of the deflection, is related to I value. Okay, so it's like deflection is equal to moment divided by EI. Okay, so deflection is divided by moment. Deflection is equal to moment divided by EI. So if we increase the I value, that is BDQ over 12, if we increase it, it means that the the member is going to have more moment of inertia, more I value. If it's having more I value, it means that deflection is going to be lesser. Once again, deflection is equal to bending moment divided by EI. If I increase the I value, it means my deflection is going to reduce. And how to increase the I value? I value is BDQ over 12. So instead of increasing our width, if I increase the depth, it will have 3 times the effect because it's already cubed. So that's why in regular beams, we try to increase the depth because it will have more stiffness. It will have more stiffness is the EI value. Okay, it will have more stiffness. It will have more of moment of inertia, and later on it will have lesser deflection, lesser lesser effects as well. Now, when it comes to the hidden beam, when it comes to the hidden beam, okay, when it comes to the hidden beam, you can see that the depth is lesser than the width. Okay, so that's one of the major differences between them. Okay, so the width is small, the depth is high. Okay, that's in the regular beam. In the hidden beam, the depth is small and the width is more. Why the depth is lesser than the width? Because we need to insert it inside the slab. I cannot put my slab to be having a huge thickness just to fit the beam. So what we try normally to do, so what we normally try to do, okay, so what we normally try to do, we try to flip, the beam so it can be inserted inside the slab. So it has a smaller depth, a bigger width, but it functions exactly the same as a regular beam. بشكل عام السلاب is carried by the beam. Okay, so البيم هو اللي شايل ثقل السلاب. Now if you can see in this particular diagram, this is the bar of the slab, this is the slab, this is the bar of the slab. The bar of the slab is coming at the top of the bar of the beam. Okay, it means كل الثقل اللي موجود في السلاب بيكون taken by the beam as well. Okay, regular scenario, regular beam, the load of the slab is taken by the beam. Even in hidden beam, due to the connection made, the slab reinforcement is coming at the top of the beam reinforcement. So it means that the slab is carried by the beam as well. Okay, this is like a 3D. You can see how the reinforcement, this is the reinforcement, the red one is the reinforcement of the slab, and you can see the reinforcement of the slab is coming at the top of the reinforcement of the beam. And this shows you that the slab is carried by the beam. How do we use hidden beam and when to use it? Normally we use hidden beam when we have large area. Okay, I have a large area, but I don't want to show a column, or I don't want to show a beam. For example, I have a majlis, or I have a mosque, for example, and I don't want to. Although for mosques it's better to use inverted beam, but in case of a majlis, for example, and I don't want to have columns inside the majlis, or a beam in the middle of the majlis. So what we normally do, if you can see here, this is a very large area. It's very huge. It cannot be designed as or it's not economically possible to design it as a regular slab due to the fact that it's very huge. It has a huge width. It has a huge length. So what we normally do in the regular cases, we provide a beam and a column. Okay, so I can place one column here. So one beam will come in this scenario, and then another beam will come here. But because of the scenario that I don't want column and I don't want beams to be seen, we provide a hidden beam. Okay, although that it's more expensive than the regular method, but it depends on the user himself. So what we have tried to do, we have tried to supply a hidden beam. So we brought a hidden beam from this column to this column, and then we brought a smaller hidden beam from this column to this beam, to this hidden beam. Now, what we had, if you remember, slab is supported by beams. Okay, slabs are supported by beams, they are not supported by columns. It means that this particular slab is supported by this beam, this beam, this beam, and this beam. Okay. Now, when it comes to this scenario, what has happened after we have our hidden beam? Now we don't have one slab, we have three slabs. So this is slab number one, supported by this beam, this beam, this beam, and the hidden beam here. Slab number two, and then slab number three. So what did the hidden beam do? The hidden beam divided my slabs into smaller slabs so they can be decided. I mean, they can be designed without having uh, without having the necessity to have extra beams or columns inside. Okay, so that's a function of the hidden beam. So you can see now this is going to be one slab, this is going to be second slab, and this is going to be a third slab. There is no specific value on how much to do the hidden beam. It depends on the span to depth ratio. This is the same reason, or this is the same question normally asked: when do we use? Because of the internet. Okay, because of the internet. Anyhow, it's recorded, so if there is anything, okay, it's recorded. If there is anything, then you can follow the recording later on. Okay, so returning back. Okay, returning back here. Okay, we said it's the same question normally asked whether we use solid slabs, or do we use flat slabs, or waffle or rugged slab, when to use this one. It depends on the economical point of view. I can use 10 into 10, 10 meter into 10 meter slab for a solid slab, but the depth is going to be too huge. In case if I went for 10 meter into 10 meter with a flat slab, the depth is going to be lesser. In that case, it's going to be more economical, so it's recommended to use flat slab. It does not mean to say that I cannot go for 10 into 10 meter with a solid slab. No, it means that it's not economical for that range of length and width. Second type is second type is inverted beam. Second type is inverted beam. Let me just try to see. Are you still having an issue with the video? Okay, I'll try to stop, go out, and then return back. Okay, so what I was explaining when it was coming to the point of hidden beam. Okay, we said the difference between a regular hidden beam, or a regular beam, and a hidden beam is mainly to the fact that one is hidden, one is seen. The second difference between them, that for a regular beam the depth is more, the width is less. For a hidden beam, so it can be entered inside the slab, the depth needs to be smaller, the width needs to be the width needs to be more. Okay. Um, but we have said once again, in both scenarios, in both scenarios, the slab load is carried by the beam. And if you can see, this is happening because of the detailing. That's why it's very important for you to understand the detailing. You can see the reinforcement of the slab is coming at the top of the reinforcement of the beam. It means that the weight of the slab is carried by the weight of the beam. So the beam is taking all the weights of the slab. Okay. An example. This is a 3D. An example of just to return back. Once again, this is the red. This is the red bar is the slab bar. Okay. So you can see the reinforcement for the slab is carried out by the or is taken by the reinforcement of the beam. Okay. Now to explain this scenario, we have said uh, if we are having a large area, which is either a mosque or it's a meglis, for example, more into a meglis mosque. Normally, we prefer to use inverted beam or other systems like waffle or rabbit slab. But if we have a large area, and we want to design it, we can see that this slab is a little bit big in the sense that it has a bigger length and a bigger width. If we design it regularly, as a solid slab, what will happen? It will happen that the depth of the slab is going to be too huge, because once again, the depth of the slab is depending on the span. Your span is huge, the depth is going to be huge. That's why I was talking about the span to depth ratio. A lot of people are going to ask you, when do we need to go for the solid slab, when do we go for the flat slab, waffle, ribbed slab, whatever type of a slab. And the answer, you need to answer that question carefully, because the fact that I can make a 10 into 10 or a 12 into 12 meter solid slab, but if I go for 12 meter, the depth of the solid slab is going to be very huge. Okay, if I go for 12 into 12 meter, the depth for a flat slab is going to be lesser than the solid slab. And in that scenario, the flat slab for 12 into 12 or 10 into 12 into 10 is going to be cheaper than the solid slab. So it's not about that I cannot make it in that size, but the best option according to the economy point of view for that particular range of span is this option. Okay, so normally we say 5 to 6 meter is going to be better to go for a solid slab. If it goes more little bit, we can go for a flat slab. It does not mean that I cannot use solid slab, but because of the economy point of view, this particular system is going to be the best system. Okay, now if you can see, this is my slab, and the slab is supported by beams. So this slab, the whole slab, is supported by this beam, this beam, this beam, and this beam. Okay. Now this slab is too huge. What I can do, if it's a regular area and there is no issues to have a column, then I'll be placing one column somewhere here. Okay, and then I'll connect the beams. But in case of a person, in case of a customer or a client, he does not want to see the column, he does not want to see the beams, we cannot go for beams. As a structural engineer, you need to get him a solution. So one of the solutions is to go for a hidden beam, so he will not be seeing a beam, he will not be seeing a column. Okay, so what we are trying to do here, we'll try to reduce the area of the slab. Okay, we are going to reduce the area of the, once again, for the questions, I'll come later. Keep your questions for the last portion. Okay. Okay. So, what's the function of the hidden beam? The function is to reduce the size of the slab. So, what we have tried to do here, we have supplied two hidden beams. This is one hidden beam from one column to another column, and there is another hidden beam from one column to the beam. Now, what has happened? Instead of having one big slab, we are having slab number one, slab number two, and then slab number three. So now we don't have any issue in terms of the deflection, or in terms of deciding or designing the depth of the depth of the slab. Okay, and this is another picture showing that this is going to be a slab, a slab, a slab. So once again, hidden beam is used whenever the client does not want to see columns or regular beams for large areas. Whenever we have walls but we don't have a beam, okay, let's say that we don't have a beam in that particular area and there is a very huge load, linear load like a wall, then it's better to keep a hidden beam in case of a flat slab, for example. In case of flat slab, regularly we don't have beams. But if I have a linear load, a very huge block work inside a flat slab, if I keep that linear load, it will cause me a huge deflection because of the point load system. So in order to avoid that thing, normally we supply a hidden beam, okay, or we supply a cab or other solution. It depends on the scenario. Okay, so once again, the function of the hidden beam is to reduce the sizes of the slabs, to divide the bigger slab into smaller slabs so they can be designed without the necessity of extra beams and extra column. It's more expensive than the regular system, but that depends on the customers. Now, a lot of customers, they don't want to see uh, columns and beams inside their areas. Second is going to be inverted beam. Now, before going to go for the inverted beam, you need to understand the different type of beams. Okay, so this is, if you can see here, uh, this is a regular beam. Okay, this is whatever we call it as a regular beam, whether it's a T section, whether it's a rectangle, it depends. So here it has been designed as a rectangular section. If it's taken to be this one, then it's a T section. Okay, now here if you see, this beam comes at the bottom of the slab, so we call it as a regular beam or a dropped beam. Okay, we call it as a regular beam or a dropped beam. So this beam, all of them are regular beams. This beam is looking something different. This beam is called to be an inverted beam. Inverted معنى معاكس. So instead of going down, it's going up. Okay, and once again, it depends on the necessity of the building. So for example, if we have uh, I'll give you two scenarios. One is a mosque. So in mosques, normally we don't prefer to see a lot of beams because in mosques we have bigger areas. If you keep seeing the beams, you will see a huge number of beams. So normally what they will try to do, we are using it here a lot in Oman. We are using inverted beams, okay, for the mosque. Another thing, instead of using a parapet wall, a parapet wall is used as at the roof. So instead of using a parapet wall, for example, I want to use a concrete. For example, my height of that wall for the parapet was a bit huge. If we keep a regular block, it will be affected by the wind or lateral loading. So I want to go for concrete, for example. If I want to go for concrete, then my beam is not going to be down; it's going to be up. So it's going to be an inverted beam. Z type of a beam, if you have two different levels, like regular slab and sunken slab, you'll be ending up to have Z type of slab. So sunken slab, regular slab, and this is the cantilever slab where there is no column supporting this particular beam. So this beam, there is no column supporting it, so it's a cantilever. It's a cantilever beam. Okay. So if you go and see the detailing of an inverted beam, it works exactly the same way as a regular beam. It's designed exactly the same way as a regular beam. The only thing that instead of keeping it dropped to the bottom, it goes inverted to the top. And the fact that if you can go and see, once again, you can see that the slab reinforcement, the slab reinforcement, the tension reinforcement for the slab is taken by the reinforcement of the beam. So once again, the beam is carrying the slab. In regular beams, the slab is carried by the beam. In hidden beam, the slab is carried by the beam. In inverted beam, the slabs are carried by the beam. So in all scenarios here, the slab is still carried by the beam. The load of the slab is going to the beam. The only thing instead of keeping it down, we are keeping it up, exactly the same design. The only thing, I don't need it at the bottom, I need it at the top. Okay, this is another example, and once again you can go and see here that the reinforcement, the tension reinforcement or the main reinforcement, main bottom reinforcement of the slab is taken by the beam bars. Okay. Here, if you can go and see, these are whatever we call them top bars or compression bars. These are whatever we call them the blue ones. These are whatever we call them as tension bars for the beam. It depends on the position, but this is the tension bars, compression bars. These are whatever we call face bars, or we call them as side bars. Some people are calling them side bars or side reinforcement. Others are calling it to be others are calling it to be face bars, side bars or face bars. And normally we are keeping them if the depth of the beam is going to go more than 750. Normally here, or according to the BS, if it's going to go more than 750, then you need to supply face or side bars. Okay, so this is an example of inverted beam. You can see that the inverted beam is going above the level of the slab. Um, Once again, at the top, so instead of using a parapet, they have used an inverted beam system here, and you can see that they used different type of slab system here. This is more into a lightweight uh, concrete system, more of something similar to a ribbed system, something similar to whatever we call it as a Hordy system, where we are reducing the content of concrete. Since concrete is very heavy, we are replacing it with other materials like blocks. Here in Oman, they started to use blocks, or they started to use lightweight concrete or lightweight blocks as well. So it will make our slabs lesser in weight. It means that the beams are going to carry less load. It means that the cross section of the beams are going to be lesser. Cross section of the columns are going to be lesser. Cross sections of the foundation are going to be lesser. And finally, the final estimate of the building is going to be lesser than the regular system. Although we are not having a lot of experienced people who are working in this particular field or this particular slabs in Oman, but they are starting already. So this is showing you like an inverted beam. Inverted beam is very common in Saudi Arabia. Uh, Another thing in Saudi Arabia which is common, they don't have the water tanks. They don't have the water tanks in. Uh, they don't have it in the roof or penthouse. They'll be having it at the bottom. For the question, I'll be coming. I'll be coming for the question. Can you hear me now? Because I think the wireless headphone has finished in terms of battery. Can you hear me now? Okay, so we'll proceed. Okay, for the questions, I'll answer them later. Now, for the sunken slab, we use sunken slab a lot in Oman. This is a this is a picture from an illustrated picture from your advanced RC design. And once again, a sunken slab is a slab uh, that is made wherever there is a necessity of connection or water connection. So you can see this is a regular slab. This slab needs to be sunk down. Sunk down معنى ننزلها شوي. I need to sunk this particular slab down so that the connection, the, the pipes and the connections, the pipes and the connections are going to be made, and then finally the level of the level of the floor is going to be the same. I don't want to see that my bathroom or my toilet is having an elevated level compared to regular the regular level, and that will cause you as well an issue in terms of water drainage. Okay, so what we normally do, we sunk the slab, put the pipes, and then backfill. So this area is backfilled. Okay, it's backfilled with lightweight concrete or it's backfilled with soil, and then finally we are going to have the same level here. So once again, we are sunken, we are sunkening the slab, lowering the slab, putting the pipes which are required, backfilling with the light material, whether it's sand, whether it's going to be a lightweight concrete, and then we're having the final finish. Okay, and this is an illustration. So this is the regular slab, this is the sunken slab where we are having the pipes. After that we are going to backfill. Why do we backfill? Because we need to protect the pipes, one. Second, we need to reach to the same level. Okay? So backfilling till we reach to the finishing level, and then put whatever tiles or granite or whatever finishing material that you are having. Okay, and this is how it looks like. This is how it looks like, and this is whatever we say, either to supply a rectangular beam here supporting both the slabs, the regular slab and the sunken slab, or we have a Z beam like whatever we have shown earlier in terms of beams. Again, of course, you need to provide a waterproofing, since water connection is happening a lot here, and you don't want your reinforcement to be disturbed. Okay. Mainly in Oman, we use a rectangular section rather than using a Z section for the beams here. Now, how to see that? How to how to know the sunken slab? The sunken slab normally are hatched. So if you see any structural plan and you see that the slab is hatched, it means that this slab is sunk by a certain value, and that value is going to be mentioned in the general notes. If you remember yesterday, I have shown you the general notes where we are showing the grade of concrete, the grade of steel, the covers, whatever requirements. We are showing how much is going to be the sunk of these particular slabs. Now going for the slab layout. So these are whatever we have taken earlier were very important for us to understand before going to the different layouts here. So going for the slab layout. Now this is a ground floor layout. Now one thing to be understood here when it comes to the ground floor, for us structural engineers, we don't design, okay, we don't design a ground floor. Okay, we don't design in the structural software, we don't design a ground floor. And the reason is that the ground floor is supported by soil directly. It means that it's not suspended. Suspended floor اللي هو عبارة عن السقف أو الفلور اللي is not supported، يعني ما كل له supported by something. It's only supported by beams. أغلبهم ماكن فراغ. So it's suspended معلق. When it comes to ground floor, it's not the case. If you remember, for the ground floor, whatever pictures we have shown earlier, the ground floor is laying down exactly on the ground. Okay? And so it has been backfilled, and after the backfill we have the ground floor. It means that all the loading will be taken by the ground. I don't need to design it using the software. What we need to do, we need to supply a mesh. Okay, we need to supply a mesh of it depends. Sometimes they are using 8 into 300 or 10 into 300, and this reinforcement we are supplying only for the purpose of shrinkage and to avoid cracks in this particular type of slab. So when it comes to the ground floor layout, you will not be seeing any slab. You are only going to see plinth beams. So plinth beam 1, plinth beam 2, plinth beam 3, and it goes on. Okay, so we don't see any slabs in ground floor layout, and the reason that we don't design it normally, it has a typical detailing, which is a mesh, and a typical thickness. Going for the second floor layout. Now, if you can see here, now between the beams you are seeing slabs. So these slabs are to be designed. Why? Because once again first floor هو عبارة عن سقف مال الجراوند. So when it comes to the ground, we don't design because it's supported by the soil. When it comes to the roof of the ground or the floor of the first floor, it's suspended. So if it's suspended, it needs to be designed. Why? Because if it's suspended, there will be bending, and this bending is to be taken by the reinforcement. I cannot say that there is no reinforcement required. Now, for me to understand, we have already highlighted. So we have S1, S2. These are noting the different slabs. So slab number one, slab number two. What are these directions? It means that the reinforcement is going in both directions. Okay, it means that the reinforcement is going in both directions. Okay, here this is going to be a solid block. Okay, this is a solid block where we don't have beams, if you can see here. Okay, or even if there are beams, we don't have columns. Okay. Another thing that you need to have, um, or another thing that you need to know, um, here, that we don't have length beam anymore. The length beams are going to go in the ground. Once again, you need to know that these are sunken slabs, these are regular slabs. Okay, so from the first floor layout, I should understand where is S1, where is S2, where is S3, and it goes on. How to know the direction of the reinforcement. So I know the direction of reinforcement from here. For me, whatever is important is going to be going here. Okay, so if you go and see slab number one, it says for you for all slab number one, whether it's sunk or not sunk. For slab number one, we are having in the bottom, we are having H1 or H10 at 150. So we're having 10 diameter of high grade steel, which is 500. So we're using 500 steel because in the market normally whatever we are having right now is 500. So whether you design for 460 or you design for 500, it does not have any major impact. Okay, so H is representing 500. So in slab number one, we are using 10 diameters, and the spacing between each and every bar, center to center, is 150. And the same thing going for the long bars. Okay, so if we are having a slab, this is our slab. Okay, if we are having our slab, then we in the middle, since this is going to be a span, we are talking about the span. In the middle, we are having X reinforcement, and then we are having Y reinforcement. So this is representing the short span. This is representing the long span. Now, when it comes to top at the support, so at the junction, you should know that the reinforcement is going up. Okay, at the junction or at the support or at the beams, the reinforcement is going to go up. In that scenario, we need to have short span and we need to have long span. Okay, I'll try to show you in detailing later on how it's long span, short span, top at support. I'll try to show. The same thing for S2. We are having short span for bottom, and then we have long span. So in the middle, always we have two reinforcement, long and short. At the support, we always have short and long. Whether it's discontinuous or continuous, in reality, when it comes to designing, we are supplying reinforcement at the top, even if the moment is considered to be zero due to the discontinuity, because we cannot assume that there is no connection between the beam and the slab, since if you remember, the beam and the slab are bored together. نصب الكونكريت للاثنين مع بعض. It means that they are connected with each other, especially that there is a reinforcement between them. So in order to counteract that particular moment, we are supplying reinforcement. So whether it's discontinuous or continuous, there will be a reinforcement at the support. And once again, it differs the thickness here. Thickness for S1 is 160, and it goes on. For S2 is 180, for S3 is 160. So in the slab layout, we don't mention the length. Okay, so for the contractor, he does not need to know the length. For me, I need to know that this is slab number one, and for the slab number one, I'll place the first bar after 150. If I'm talking about S1, after 150 millimeter, I supply the second one till I finish that particular slab. The same thing goes for slab number two and slab number three. So we don't mention the length. Why? Because if you go and see here, this slab number one is different from this slab number. So we don't mention the length or dimensions in terms of the slabs, but we mention only the diameter and the dimension with the thickness. Okay. The same thing goes for the roof layout. Okay. The same thing goes for the roof layout. Uh, Sunken slabs. Some of the sunken slabs are there. Uh, this is going to be the roof. So some certain sunken slabs are there. This is the final. If you go and see, this is going to be this one. This portion is going to be at the top of this particular portion. This particular portion is going to be above the staircase. Okay, so at the last roof, they are not making any sunk here. Okay, if you can see, sunks are there, but when it comes to the final roof, there is no necessity to have sunk because we don't have any requirement for water connection. And the same thing goes for reading the layout. Once again, we don't mention the dimensions. The only thing we mention the diameter and then the spacing with the thickness. Okay. Now, when it comes to, or let me take you to the detailing. Let me take you to the detailing, so you will understand. Tomorrow is supposed to be the detailing, but just to show you what's the meaning of the top reinforcement bar and bottom reinforcement bar and hose. Okay. Now, if we go and see here, this is whatever we call it as span reinforcement. Okay, this is whatever we call it as span reinforcement. Span is between the support. So this is support number one. This is support number two. This reinforcement is acting as the span reinforcement. اللي تحت, the bottom one, is considered to be the short span. The circle ones are considered to be the long span. When it comes to the support, بتلاحظوا إنه الحديد في the top, we don't have it at the span, we have it only at the support. Okay. When it comes to the support, once again we have long bars, we have the circles. For the long bars اللي يكونوا فوق إنه عبارة عن short span, and then here we have the long bar. So this is span bottom, okay, or short span, long span, support short, and then support long. Okay, is it clear for this particular point before going? So for the span, we are having the reinforcement at the bottom. This is going to be short, this is going to be long. For the support, we are having the reinforcement at the top. So this is going to be the continuous bar, we call it as short, and this is going to be, the circles are going to be long. So these are the things that we have highlighted. Okay, these are the things that we have highlighted here. Okay, so once again, even if you know how to read the layouts, you should know how to read the detailings as well. Okay, this is what we have tried to illustrate here, if you remember. So for the bottom, we had short span reinforcement and we have long span reinforcement. For the support, we had short and long as well. This is what I have explained for you earlier. Now going for the beams layout. Okay, going for the beams layout, and once again the same layouts are there because we said for the slab and the beams are the same. The only thing that we are going to concentrate on the beam schedules now. Okay, the same layout for the beams and the slabs, since they are both together, since they are interconnected together. Okay. Now what we need to concentrate at, we need to concentrate on this particular beam schedule. Okay, now if you go and see here, we have different terminologies. Okay, we have b1, b2, b3, b4, b5, cb, hb, bb, or pb. B is representing the regular beam, so beam number one. Okay, so if we go here, there is beam number one. Okay, so this is beam number one, regular beam. Beam number two, once again regular beam number two. CB is a cantilever beam. CB is a cantilever beam. Okay. CB is a cantilever beam. HB is a hidden beam. PB is a plinth beam. Okay, so it depends on which layout I'm saying. So if I'm saying the ground floor, because the plinth beam is there, you can see all plinth beams are shown. So plinth beam 1, plinth beam 2, and 2 also. Okay, I'll be explaining about the bars, but let me just show you the the different uh, so the different types of beams. So this is going to be a hidden beam. As you can see, this is going to be a hidden beam. Okay, this is the hidden beam. For a cantilever, I'm not sure whether they are available or any cantilever is available in this particular layout. I don't think there is a cantilever beam here. Okay. Now, in order for you to read the schedules, you need to understand what's the meaning of main bottom, what's the meaning of top main. Previously in slab we used to have short and long, because normally in slabs we have two side reinforcement. And when it comes to the beams, we don't have two side reinforcement, we have only one side. Okay, we have only one side reinforcement. So we have main bottom and top main. So whenever we are talking about the span, once again the reinforcement is called to be main bottom. Whenever we are talking about the support side, we talk about top main. Okay, so bottom between the supports we call it as bottom. Okay, why it's main? Because we have other things like extra, and we have links. So main reinforcement is 2 bars of 14 between the supports. When it comes to the support, we are having 2h of 14, so 2 bars of 14 diameter, 2 bars of 14 diameter. Now what does it mean, the bottom extra and the top extra? um, Now, if you remember, when it comes to bending moment diagram, okay, when it comes to bending moment diagram of beams, uh, normally we have a parabolic. Okay, we have a parabolic shape. If you remember, um, okay, in the sides the bending moment is lesser. In the center the bending moment is more. So what we need to provide normally, we provide one bar from the beginning till the end. If that bar is sufficient for both the sides and the center, then one bar is sufficient. So here for beam 1 or beam number 1, 2h of 14 is sufficient for the sides and it's sufficient for the center. Okay. Now if the bending moment is huge, you will have very different values in terms of sides and then the center for the curvature of the parabolic. So what happens, we supply like this case, which is b2, we supply 2h of 16 for the whole beam. And then for the center, since the bending moment is huge, 2h16 is not sufficient, we supply extra bars at the center, which is 2h of 16. Is it clear? The same thing for the top extra. When it comes to the support, normally, okay, okay. So when it comes to top extra, once again, if this is a support, you remember that the bending moment goes up and then it goes in this way. Okay, so we have uh, like a curvature going up. If we take it further, the curvature goes like this, straight in the support region, and then it goes down once again. So what we need to provide normally, we provide we provide main reinforcement here. Okay, so certain portion goes here, certain portion goes here, and certain portion goes in the other side. So three zones. This is the curvature, the main top. Okay, for the peak. Okay, اللي هي أعلى قمة في المثلث. If we are going to see the parabolic in this way, we have this portion which is the maximum, this side and this side. Now, what we need to provide normally, we provide one reinforcement at the top. Okay, we provide one reinforcement at the top. If it's sufficient, then no need to have extra reinforcement at the top, like beam number one. If it's not sufficient, then normally what we need to do, we need to supply extra moment at the peak. Okay, so this is sufficient here, this is sufficient here. We need to apply extra reinforcement at the top. Okay, so once again, okay. You cannot hear me now? Hello? Okay, okay. So once again, for understanding this one, you need to understand the behavior of the bending moment. When it comes to the span, we are talking about a parabolic. Okay, for a parabolic, lesser bending moment values here, more bending moment value here. If I supply one reinforcement from the beginning till the end, it's okay for the sides and the center, which is the peak. Then it's fine. No need to supply extra reinforcement. If it's not sufficient, it's sufficient for the sides because they have lesser bending moment. For the peak, because of the parabolic, the maximum at the center. Now we need to supply extra reinforcement if it's not sufficient. The same thing for the top, extra reinforcement, and the curvature goes like this. So we have smaller values here, extra, or the peak is going to go here. Now what do we need to do? We need to supply one reinforcement from the beginning till the end for the top bar. If it's sufficient, then we are okay. If it's not sufficient, then at the peak, which is the center, we need to supply extra reinforcement. In order for you to understand that particular thing, we are going to go for the detailing. I'll just show you the detailing. Although it's tomorrow's session, it will make you understand a bit more. Okay, going for the beams. Okay, now what happens? This is the first support. This is the second support. The reinforcement for the bottom bars always goes from the beginning till the end. It will not be stopping at anywhere. البار تشوفه من البداية للنهاية. It goes even to the other sides. Okay, now what happens? The bending moment, my bending moment goes according to here. If you see my bending moment, the peak for the span is in the center. هنا شوية أقل، هنا شوية أقل. So normally what we do, we supply from this particular region to this particular region, we supply one bar. If it's sufficient and it's sufficient for the peak, no need for extra bottom bar. If it's not sufficient, then we need to provide extra bar like how it's shown here. So this is the bar. Because of the bending moment is huge, we need to provide extra bars at the peak of the curvature. The same thing goes for the cantilever. You can see here we supply normally one reinforcement. If it's not sufficient, we are going to increase or put one bar for the peak. You can see here this is the top main from the beginning till the end. If this is not sufficient, we need to supply another one which is called top extra, and we are not placing it everywhere because this is going to be the bending moment for the top part. Okay, we supply it where the peak is. So this is going to be the peak portion. Just to illustrate, we are going to take this one. عندنا هنا we have the support part, we have here the span part. We supply one reinforcement for the span. We supply from the beginning till the end. Okay, so we supply from here to here. If this is sufficient for each and every point of bending moment, then no need to supply extra reinforcement. If it's not required, if it's not sufficient, in the maximum bending moment area, we supply extra reinforcement here. When it comes to the top, we don't provide from the beginning till the end. We provide only for the area of the top reinforcement. Okay. Now, if we supply one bar here, or we supply bars at the top, if they are sufficient for all the areas from this part to this part, then no need to have an extra reinforcement. But if if the maximum bending moment is not sufficient, or if the bar is not sufficient to take the maximum bending moment for the support, we need to increase. Where to increase? We will not increase on the sides, because the bending moment on the sides are lesser. The maximum bending moments occur at the side. Okay, so hope that's clear. If it's not clear, let me know so I repeat it once again. Is it clear? Are we okay with it? Is it clear for you? Okay. Okay. After the beams layout, I mean, is it clear? Okay. After the beams layout, we are going to go for the columns layout. So this is going to be the columns layout, and in the columns layout, we don't show the beams normally. Okay, we only show the columns. Okay? And if you see here, we have different columns. Column number 1, column number 2, column number 3, and normally the columns will be categorized based on their sizes. So we have C1. Okay, we have C1. So okay, so we have C1. In this C1 we have H8 at 150, and then we have 8H of 14. Uh, so what we have, 8 bars. So there are 8 bars of 14 diameter, and then we have H8 of 150. So the spacing for the link is 8 millimeter. The spacing between one and another link is 150 millimeter. The same thing goes for uh, the C2, which is 10H16. So we have 10 bars, okay, of 16 diameter. That depends, of course, depends on the loads. Uh, we might be having different cross sections for the same column from the bottom to the top. Normally in the bottom load يكون أكثر. في الكروس section it might be more. In the top regions, the cross section is going to be lesser because of less load. So you can reduce the column size, although it's not preferable. For Oman, it's very rare that we are changing the cross section, but you can change the cross section as well. Otherwise, you can keep all the cross section from the beginning till the end to be the same thing. Okay. One thing that you need to understand when it comes to the columns as well, it's not shown here unfortunately. It's shown in the beams. Okay, let's go to the beams layout. If we go for this particular schedule, okay, now you can see here for the beams we have the links. I didn't discuss the links of the beams. So we have H8, so 8 diameter of 200 spacing, H10 of 200, H10 of 200. Now you learned in the college, you know that we use normally T10 at 200, T12, or whatever T is 460, H is 500, 8 is the diameter, 200 is the spacing. But there is something new which is coming here. We know what's H8 and 200, but we don't know what's 4L and 6L. Okay, when it comes to 4L and 6L, they are referred to legs. Okay, so we are talking about 4 legs here, and then here we are talking about 6 legs. What's the meaning of 6 legs? It means how many sides of links are there. Okay, so if we go back to the detailing, for the beams, okay, it's not shown here. take you to let me take you to the hidden beam. Okay, now if you go to this hidden beam, how many links are there? There are two links, right? You can see that this is the first link and this is the second link, but it's not done in this way. Okay, what we normally do, we normally have one link, okay, where two legs are there. So this is the first leg, this is the second leg. If it's two legs only, we don't mention the number of legs. Now here I have one, I have two, I have three, and then I have four. So in this particular situation, we call it a four legs uh, beam. Four legs in the sense four sides are there. So leg number one, two, three, and four. Okay, that's the meaning of 4L or 2L or 3L. Normally for 2 we don't mention the number of legs, and that's only for beams. Normally we don't mention it for the columns. Finally, we are going to go for the foundation. Okay. And once again, you can see in the foundation we have different types of foundation here. uh, we have F1, we have F2, CF2. um, if the foundation are uh, touching each other or very close to each other, normally we we supply a sheet between them. Okay, we supply a sheet like this one. It's a flexible uh, polyethylene sheet of 20 mm. Okay, so that the two foundation will not be affected. When it comes to the schedule, once again we need to understand CF1, CF2, that's combined foundation 1, combined foundation 2, F1, F2, F3, F4, F5, and goes on. That's a regular foundation. Now, when it comes to raft foundation, for the raft foundation, we don't normally mention the sizes. We just write as shown in the foundation layout. Okay, for CF1 and CF2, if it's regular shape combined foundation, we write the sizes here. If it's not regular size, we can state that it's as shown in the foundation layout. Now, if we are taking, for example, CF1, we can see that the size of the RCC, foundation itself, is 4.6. This is the length. 2.1 is the width. 550 is the 550 mm is the depth. So we have length, width, and then the depth for CF1. Okay, now if you remember, we talked about the BCC. We said for the BCC we need to increase 100 mm from each side. So if we are talking about 4600 for the foundation, we need to increase 100 mm from this side, 100 mm from this side. So it will come the length of the BCC to be 4800. If the width of the foundation is 2.1, we need to add zero point 0.1 from here, zero point 0.1 from here, so this is going to be 2.3. The depth of the BCC, as we said, is going to be 100 mm. The foundation is exactly reinforced exactly the same way as regular slabs, regular two-way slabs. So we have bottom short, we have bottom long. If it's a combined foundation, you remember for a combined foundation we have top bending moment and we have bottom bending moment. Since there is top and bottom bending moment, it means we have reinforcements for the bottom and we have the reinforcements for the top as well. Okay, typical detailings are shown here. So this is a typical footing section. This is a central strip footing for a wall. So if we are having a wall, for example, like this one, so here we are having a wall. This is a typical section. This is a blunt beam as well. Okay, and this is the ground level. So this is representing your ground, uh, your blunt beam, and this is the ground level, and these are the walls which are there. Okay, Some details are shown here. What's the grade of concrete? What's cover as well? It can be shown uh, in the foundation layout. How the reinforcement are shown. We have short bar and we have long bars here. Um, this is an illustration of how to read the drawings. We need to know the different components. For the beams, we learn that we have plinth beam, we have cantilever beam, we have hidden beam as well, and regular drawings. And then for the slab, we should know what's a sunken slab, where is it, how to find it in the drawing. We should know how to read the reinforcement, and I explained for you what's the meaning of main bar, what's the meaning of extra bar for the bottom, extra bar for the support, for the columns, how to read it, whether we can change the cross section for the same column or not. Um, and then we have discussed the links for the beams, number of legs, how it's affecting, uh, and then finally we ended up with the foundation. So whatever we have done today, we are going to expand it further tomorrow. We are going to go deeply in detailing. I have already explained some of the detailing for you, so you'll understand how the schedules are made in this scenario, on this particular way. And based on the detailing, after we understand the basic detailing, we will be able to do the estimation. Because finally, if you didn't know how to read the drawings, you cannot do your detailing. If you didn't do your detailing, then you cannot estimate the project. And one of the major things, if you are working in construction, that you should know how to properly estimate. And this is one of the basic questions normally is asked. uh, how to, for example, how to estimate the quantities for a concrete column, how to I mean, they'll give you a certain section and then you need to quantify the quantities, beams and slabs and foundation. For a column, it's very easy, but what to do for a beam, for a column, for a slab, for a foundation, how to do that particular thing. By this, we have ended today's session. Apologies for taking a lot of time, but I tried to cover whatever is possible for you, so you will have the maximum gaining possible. Okay, thank you very much. Now we are going to go for the question and answer session. If you have any question, we are going to go further. And just to illustrate for you the last thing, this is the foundation, whatever we say, and this is the starter column that we have mentioned in the pictures, if you remember, and the coating of the bitumen paint, and this is the compaction of the this is the compaction or backfill that we have done, and then finally we have the grade slab or slab on clay. Thank you very much, and if you have any question, you will be welcome to ask.